So now that we've done some review of how to expand and multiply using the FOIL pattern and convert from standard form into vertex form, we want to actually learn how to do the opposite. Okay, and the opposite is actually, so we've been expanding, and what we're going to do is we're going to factor. Okay, and factoring is in fact the opposite of expanding. Okay, so if we're expanding, we're multiplying things together. Okay, so we're going to multiply those two sets of binomials, and that's an example of expanding. Okay, however, if we want to go the other way around, if we want to go from a completed trinomial, like we have here on the right-hand side of the equal sign, back into the two binomials that we had to multiply to get that, we call that factoring. Okay, so factoring is simply the opposite of expanding. So in order to do that, to factor a trinomial, and particularly a trinomial in standard form, this here is standard form, where the a value is positive 1, okay, because we're looking at simple trinomials right now. When the a value is positive 1, we want to figure out a couple of numbers that are going to match, okay? So in this case, standard form says that a times x squared plus bx plus c is going to equal the equation of our given parabola. However, if we want to break this trinomial apart into two separate binomials, then we have to split this up, okay? And so we're going to find two numbers that together are going to do the following. They're going to multiply to the c value. Okay, so they're going to multiply to the c value, and at the same time, so the c value is right here. Okay, so they have to multiply to the c value. Okay, and they also need to add to the b value. So they have to add to whatever this b value happens to be. Okay. And so when we're looking for those specifics, we're going to come up with what we're going to call our add multiply chart, okay, or our MA chart. So in this instance, we have an equation here. We've got x squared plus 9x plus 18. Okay, and so we're trying to figure out how to break this down into two different pieces. And again, we've got x in front of both of them. Okay, now we want two numbers that are going to multiply to positive 18 because that's our c value. So if we write this out, this is x squared plus bx plus c. So they need to multiply to positive 18, and they need to add together to be positive 9. Okay? So if we're going to try and figure this out, we need to create what we're going to call an MA chart. Okay? And so I know they have to multiply. So here's my M. They have to multiply to 18, and they have to add, that's the A, to positive 9. Okay, so I'm just going to go and take a look at the factors, the numbers that multiply together to get me 18. So I know that numbers that multiply to 18 are positive 1 and positive 18. And those two numbers, they add up to 19. I know that positive 2 times positive 9 is also going to multiply to 18, but when I add them together, that gives me 11. I know that positive 3 times positive 6 will also give me positive 18, and when I add them together, that gives me positive 9. Okay, and so in this instance, I know that this connection here, this positive 3 and positive 6, that those two numbers meet my MA requirements. Okay, so I'm going to end up with x plus 3 times x plus 6 is going to give me this outcome when I multiply it together. Okay, So x plus 3 times x plus 6 should give me that. So what I'm going to do is I'm actually going to multiply those two pieces together to confirm, to check. Okay, so if I do x plus 3 times x plus 6, if I multiply using my FOIL pattern, it's going to give me x squared plus 6x plus 3x plus 18, which ends up being x squared plus 9x plus 18. Okay, so those two things are equivalent. They equal each other. Okay, and so I have correctly factored this particular equation. Okay, if I look just over here to the right for my second example, now I need in my MA chart, I need to find two numbers. I need a number that's going to multiply to my C value, which in this case is positive 15. And it has to add to my B value, okay? And that means positive 8, okay? So again, I'm going to go through steps in the process. Positive 1 times positive 15, and that equals positive 16. Positive 2, well, that doesn't work because positive 2 does not divide evenly into 15, so I'm going to go with 3. So 3 and 5 multiplied together end up at 15, and 3 plus 5 gives me positive 8. Okay, so they have to multiply to positive 15, and they have to add to positive 8. So I've determined that x plus 3 times x plus 5 should work. So let's go down and check it, just to be absolutely sure. So I've got, oh dear. So here I have x plus 3 times x plus 5. So if I expand this out, that gives me x squared plus 5x plus 3x plus 15. And then if I collect my like terms, it leaves me with x squared plus 8x plus 15, which is what I have as my original equation. Okay. So what we're going to do is we're going to continue and factor other questions that are in there. Okay. So we've done a bunch of examples, so now I'll ask you to go through and factor some of the other pieces.